So I thought I would show you my latest project, which is this software to detect fish, which I'm going to place in the river Moälven, close to here. Oh, we're going to detect faces first, just to show you kind of the basic principles at work here. The end goal is to have an algorithm that is this smooth. If I stand up here, you can see my face and you can see the lips moving. It is detecting every part of my face, even if I turn my head a bit. And really, well, really fast algorithm. Now this face detection is basically a pattern that you tell the computer to look for a pattern, and the pattern is a face. And this lamp up here in the ceiling is not a face, so it's not going to be detected. It doesn't fit the pattern. And once you have that pattern defined, it is very fast. You just need to look for that pattern. The problem is, when you're going to detect fish, how do you describe that pattern? Because a fish looks very much like a wave in the water, or it could look like grass or leaves in the water. If we look at some of the training I did with the neural network I used. So for example, we have this picture of a fish. This is what a fish could look like. But a fish could also look like this, that you have lots of waves and shiny things, and all of these are fish and should be detected. But it's kind of difficult to say, why is this and this the same thing? It doesn't. The shape and the pattern is quite difficult to define. So to define that, I used a neural network, which is what you call artificial intelligence, which is, to me, a bit of an overstatement. But basically, you have a small piece of software that performs the same function as a neuron in the brain, which is just to give out a signal at a certain type of input. And if you combine these neurons in a specific way, that forms a pattern, same as the pattern that detects faces. If you tell them that, well, we're looking for fish here. As it turns out, and let's see if the recording is going to start lagging now, because this requires a lot of power from the computer, and I still have it. This is a fast computer. Let's show you what it is. We got 16 gig of RAM. We got 16 cores in the processor. It's an Intel i7 something, a new one. It's a pretty fast processor, but if we start detecting fish in this picture, let's get some fish shown to the camera. See if you... I'm holding up my cell phone now to the camera, and as you can see on the screen, hopefully you can see it on the screen, nothing is actually happening. Because this takes so much computer power that it's... Oh, there you go. You got a phone. And let's see if we get some fish detected here. So you can see it really requires a lot of power. If you're really fast, you can see a short blink where it says that yes, it did detect a fish. There's a green text and something. Because this takes so much power from the computer. I tried something else. I tried to just filter out everything that is the background. Things that are not changing should be removed once this artificial intelligence stuff stops running. May take a while. Okay. So now you see that it's still running. Why is this so difficult? See, it's still working a lot, trying to process pictures with this AI. Even though I stopped it and switched over to this. See if I switch to faces, is it gonna get easier? Oh, maybe not. How about if I just restart it? Oh. Where do I have this? Whatever. Okay, moving objects. So now you see this bottom part is white. And it's white because all of this background is filtered out because it's not moving, it's not changing. The pixels are the same all the time. But if I put my hand up here, you should be able, if I stretch my finger, there you see my finger comes up and there's a red frame around that finger because it's like, oh hey, this is a moving object. I'm going to track this moving object. So in this way, I can track any type of object and save it. Problem is, water is moving all the time. It's not a wall or a ceiling like here. So I'm gonna get tons of pictures of water. And then I would have to build some kind of function to filter through that, and then we're back to this AI, which takes a lot of power. So what I need to do is take this pattern that is output from the neural network and get it to this really fast face detection type of pattern. So that's what I got left to do. But it is working right now. You can see this here. Let's see now, the time is 20:04. Should be some pictures here. Whatever. Basically, I get these really tiny pictures from the screen of the fish that were detected. And then I get the lamp, which is thought was a fish for a second. But yeah. So it can detect fish. If I look at just any type of object, I didn't save those images. Okay. I did some changes to try and solve the overload on the processors. I guess I removed the image saving port here. Anyway, this is just crazy amount of images that is going to be stored if I save every object. So it is better to just run this pattern that the neural network produces. And you can see here I get also that it's 84% sure that this is a fish, 80% sure maybe this is the lamp that it found. It's only 80% sure, 99% sure, yeah, this is definitely a fish. 77 is probably the lamp again, and so on. Or maybe if it's a half a fish, it's going to go down like this. So this is the data I will save as a counter and get how many fish are passing every day at the river. And hopefully that is going to work out reasonably well. And if it doesn't work out reasonably well, I have to fine-tune this somehow and find better ways of performance tuning it. Like I said, what I want is this, the speed of this. But this is not using a neural network. They use the neural network to produce this pattern, and then they refine the pattern manually. And that kind of refining is a lot of work, which you can do if you detect phases, because everyone want to detect phases, and you want to recognize people, and you want to get the mathematical relationship between the width of the eyes and everything, so you can identify people, and then you can follow criminals or politicians or whatever you want. But detecting fish, no one is interested in that, so no one is gonna put all the time necessary to do this optimization unless I do it myself. Maybe I do have to do that at some point, but right now at least I have some chance of counting the fish that go out in the river.